So the question is calculate and draw the shear force and bending moment diagram for the cantilever beam with uniformly varying load of 3 kN per meter. Now this is the given beam which is fixed at end A and is free at end B, and the span of the beam is 4 meter, where the load is simply varying from 0 at point B to 3 kN per meter at point A. So a reaction, as this is a fixed end at A, so a reaction will be developed which is known as Ra. Now how to calculate this Ra? So we can simply say that it is a triangular force, so we can simply use the area of this triangle for Ra, so that is half into base into height. So that will become half into base is 4 meter and the load is 3 kilonewton per meter. And when we will solve this, we are getting 6 kilonewton Ra. Now next we have to solve this by considering some sections. So the first section is consider section AB X distance from B. So now you can see in the second figure, so this is the beam. So we have to develop a section line here, and the X distance should be considered from the end B to the section line. So this distance will be known as small x. Okay. Now, for this section, we will be calculating the shear force and bending moment. So, first equation will be for shear force. Now, shear force equation will again be half into base into height. So, we will be considering only the triangle which can be seen up to this section line, okay, from B to this section line. Rest portion we can simply neglect it. We will consider only the right side of the section line. So when we will see the right side of the section line, so the base is X and the vertical, we are naming it as Y. So the area will be half into base into height, so that will be half into X into Y. So now next we have to use a similar triangle law, and according to the similar triangle law, we can simply use Y by X will be equal to 3 by 4. Okay, so 3 is the kilonewton per meter and 4 is the base. So with this, the value of y becomes 3 by 4th of x. Now we can easily put this y value in the shear force equation, and with this our shear force equation will become half into x into y will become 3 by 4 of x. So with this, the equation has been modified to 0.375 x squared. Now, as this x value is coming in the shear force equation, we have to consider first the x value as 0, as our beam is starting from 0 meter to 4 meter. Okay, so first is at x equals to 0, we will be simply putting the value of x equal to 0, and the shear force value will become 0 kilonewton. Second, the beam is ending at 4 meter, so x value will be 4 meter, and with this shear force value will be 6 kilonewton. Now moving on to bending moment equation, the same figure we'll be considering, and the bending moment equation will be the bending moment is always force into distance. So we will be considering force together with the distance. Okay, so the force will be same, the area, so that is half into base into height. I have already told you height was y was 3 by 4 of x, so I'm directly putting the value here. So half into base into height, this is the force, and distance we have to consider from the CG up to the section line. So CG is here for this triangle, triangular section, and this is our section line. So from here to this distance, and we know that for a triangle from CG to the vertical section, so that is always 1 by 3rd of x, and from this point to this point it is always 2 by 3rd of x. So the force is acting at this CG, and from CG to the centroidal axis will be 1 by 3rd of x. So here we have to put the distance as 1 by 3rd of x. So the equation will become minus 0.125 x square, x cube. Why this minus is there? Just because this will be your clockwise movement. So clockwise movement is always considered as negative. So the bending moment will be minus 0.125 x cube. Now again this x value is coming, so again we have to put the values of x starting from 0 meter to 4 meter. So we'll start with 0 meter. So x at x equal to 0 meter, bending moment, we have to simply put the value of x equal to 0 and we will be getting bending moment equal to 0. Same way, now our beam will end at 4 meter, so we'll be putting x is equal to 4 meter. With this, our bending moment value will become minus 8. Now the calculation is over. Now we will be simply moving on to the diagram. So this is the question. Okay, so first we will draw this, and below that we will be drawing the shear force diagram. So shear force, we can see at point B it was 0, and at point A it was 6 kilonewton plus 6 kilonewton. So it will always be drawn above the axis AB line. So we will fix the point here, and we will join this 6 kilonewton and 0 with a parabolic curve. Okay, and this will be positive shear force diagram. Similarly, when we will draw the bending moment, so bending moment same way, at 0 we have got 0, and at 4 meter we have got minus 8. So it will start from 0, and we will fix the point here below the AB line, because that is negative, that is minus 8 kilonewton. Okay, so this is minus 8 kilonewton, and we will join this minus 8 and 0 with a cubic curve. So with this, our bending moment diagram is also complete, and this is our final bending moment and shear force diagram. Thank you.